Hello, my dear students, and welcome to this session. आप सारे आ चुके हैं? Are you all with me? Any confusions? Anybody? Anything you want to ask? So, we are here. Begin. Session begin. कौन-कौन आ चुका है हमारे साथ? We have got 10, 11 likes, and how many students are here? We have 8 watching. That is 7 watching. One is me. So let's begin over with this chapter. Today we are going to do an extremely important chapter, really important, and which is considered the most difficult chapter of chemistry. भाई जब भी मैंने किसी स्टूडेंट से पूछा है कभी भी किसी भी स्टूडेंट से कोई 11th स्टार्टिंग स्टूडेंट हो चाहे 12th स्टार्टिंग स्टूडेंट हो चाहे 12th पास स्टूडेंट हो जब भी मैंने किसी स्टूडेंट से पूछा है कि बेटा कौन सा चैप्टर रिवीजन करना चाहते हो देन द सिंपल आंसर इज ऑलवेज ऑलवेज द फर्स्ट आंसर इज इक्विलिब्रियम. ठीक है, कोई ऑर्गेनिक कोई इनऑर्गेनिक कोई फिजिकल कुछ नहीं. इट इज ऑलवेज इक्विलिब्रियम. अगर इक्विलिब्रियम कहता हूं चलो ठीक है इक्विलिब्रियम के बाद कोई चैप्टर देन इन दैट केस टर्न्स आउट टू बी थर्मोडायनामिक्स और मे बी इलेक्ट्रोकेमिस्ट्री मे बी केमिकल काइनेटिक्स मोस्ट ऑफन द फिजिकल केमिस्ट्री चैप्टर्स. या फिर कहते हैं सर पूरी ऑर्गेनिक नहीं आती या फिर सर ऑर्गेनिक रट्टा नहीं मारा जाता इनऑर्गेनिक रट्टा नहीं मारा जाता. दैट इज द आउटकम ऑफ एवरी स्टूडेंट. So, as I cannot overemphasize the importance of this chapter, I cannot overemphasize the difficulty of this chapter, we begin over with this chapter. Okay? Yes, Mayuk, everyone liked the chapter, the session. And today this session is going to be extremely important. You can share this session with your friends. You can tell them that this इससे बेहतर सेशन कभी नहीं मिलेगा क्योंकि आज we are going to do it very nicely, very slowly. एक एक चीज बताऊंगा एक एक चीज एक्सप्लेन करूंगा. अपनी कॉपी किताबें ले आओ फटाफट जाओ फटाफट. आज आपके पास पेन ढंग का होना चाहिए पेंसिल पेन कॉपी बिल्कुल ढंग से होनी चाहिए. अगर आज आप पढ़ने के मूड में नहीं है तो इट्स नो यूज बीइंग इन दिस सेशन. और अगर आज आप पढ़ने के मूड में नहीं है देन इन दैट केस देयर इज नो यूज इवन ट्राइंग टू प्रिपेयर फॉर योर नीट एग्जामिनेशन. Yes, this session is that much more important. Is this clear? So this session is extremely important. Okay, चलिए. So that's Elixir dropper batch which is starting from 5th of August. यानी कि बहुत जल्दी शुरू होने वाला है. And you can use the code AVLIVE. So use the code AVLIVE to join with this session. One person has already joined. Yes, Mayuk, it's not only you. Everybody fears this chapter. So we are going to start over with this chapter, and the session for the Elixir dropper batch would be Botany 6:30 to 7:30, Chemistry 7:30 to 9 p.m., Zoology would be 9 to 10. Okay, so this is what we have. मैं one more में आ गया हूँ. Okay, use the code AVLIVE and join with us. So that's me. तो चलिए अब start करते हैं with the chapter called Equilibrium. I know everybody fears this chapter. This is a fearsome chapter जिसको हर कोई डरता है कोई ये समझ नहीं पाता कि इस चैप्टर में आखिरकार हुआ क्या. The problem with this chapter is not that this chapter is difficult one. The problem with this chapter is कि जब आपको लगता है कि सब कुछ समझ में आ गया तब आप गलती करते हो. And you are not able to understand why you make a mistake in this chapter. So let's begin over with this chapter without any confusion. We are going to start with chemical equilibrium first, and then we are going to get along with ionic equilibrium also. And please, 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 I request you, अगर ऐसी कोई चीज होती है जो आपको लगता है कि आपको समझ में नहीं आई है, just don't hesitate, ask it. Okay? पूछ लेना इमीडिएटली, ये मत मान के चलना हाँ आगे 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 चलता है चलता है आगे आगे, ऐसा मत करना। एनसीईआरटी से ये चैप्टर समझ में नहीं आएगा। एम आई क्लियर? सो एनसीईआरटी के चक्कर में मत रहना, ध्यान से हर चीज समझ लेना। तो लेट्स टॉक अबाउट द केमिकल इक्विलिब्रियम वर्ड। नाउ व्हाट इज द मीनिंग ऑफ इक्विलिब्रियम? इक्विलिब्रियम का मतलब होता है बैलेंस्ड एंड स्टेबल। अब स्टेबल का मतलब घड़े घोड़े का अस्तबल नहीं होता। वी आर टॉकिंग अबाउट द स्टेबिलिटी ऑफ द सिस्टम। नाउ most of the times, sorry to say, you don't even know the meaning of the word stable. What is the meaning of stability? So let's get along with very basic things. अब आपने अगर किसी ने बोला ना सर सर डिटेल में पढ़ाओ, तो बेटा पूंछ खींच दूंगा मैं तुम्हारी। इससे ज्यादा डिटेल में टेल नहीं हो सकती जितना मैं इस बार डिटेल में पढ़ाने वाला हूं। समझ लेना ठीक से। ओके, so that's what we call as the stability. Now let's talk about what is the word stability. Stability का एक is meaning is a situation which a system does not want to change. It's not that means ki we cannot change it. We can change the position, but we'll have to make an effort to change it. A very simple example is, let us say there are students in a class, regularly, normally sitting in a class, and then students playing in the field. Now, which of these two situation is more stable? Let's say this is the situation A. Let's say this is the situation B. Give me the answer on the chat box. Which of these is stable? इन दोनों में से कौन सा stable है? बोलो. The students sitting in a class or students playing in a field. Which one is more stable? Mayuk Sem Gupta says students playing in the field. Okay. Indu Jain says students in the class. Okay. So some say student in the class, some say student in the field. Now, could you please tell me which situation would require more effort to change? किसमें आपको ज्यादा मेहनत करनी पड़ेगी चेंज करने के लिए? To get the students from the class to field is easy, or to get the student from the field to the class is easy. कौन सी चीज अपने आप हो जाएगी? Student will come from the field to the class on their own, or the student will move from the class to the field on their own. Whichever situation they want to achieve is more stable. Now, do you know one thing? If the students have been playing for 3 hours, 3 घंटे से वो खेल रहे हैं, थक गए हैं, और वो भी फुटबॉल खेल रहे हैं या मे बी हॉकी खेल रहे हैं, हॉकी में तो 45 मिनट्स में एस्टेसी हो जाती है, ठीक है? तो आई थिंक फील्ड टू क्लास वुड बी इजी। और अगर वो 2 घंटे से पढ़ रहे हैं, then in that case class to field would be easy. Stability is not just a statement. Stability is condition dependent. Is that clear? So it is not that easy to say that which condition is going to be stable, which situation is going to be more stable. We need to know what conditions are there, in under which conditions we are talking about. Am I clear? So it may be other way around. Fine. So we have a tendency to say that the stability means low energy, but that is not a necessity. Stability does not always mean low energy. Okay. Like hot coffee in a cup loses heat and gets cold. Ice cream in a cup gains heat from the surrounding and melts. So it is more like it seems that both are trying to get the temperature equal to the surrounding. It may be gaining, it may be losing heat, it is not just to say low energy, it is situation dependent. Okay, we can say low Gibbs energy. Thermodynamics, Gibbs energy, delta G. Is it clear? So that is what we have. Yes say Mayuk Sen Gupta. If it is raining, most of us would like to come in the class. अगर आप सर्दी के मौसम में तो हीटर चलाना अच्छा लगेगा, गर्मी के मौसम में तो एयर कंडीशनर चलाना अच्छा लगेगा. ठीक है. गर्मी बहुत तेज हो रही है तो शायद बारिश में नहाना अच्छा लगेगा, सर्दी तेज हो रही है तो शायद अंदर छुप के रजाई में दुबक के बैठना पसंद होगा. ठीक है ना. Okay. And if so happens that in your class your girlfriend or boyfriend is sitting, then in that case maybe फिर क्लास में बैठना ज्यादा अच्छा होगा. Situation dependent. ठीक है ना. और ये भी हो सकता है कि तुम्हारी गर्लफ्रेंड अगर क्लास में बैठी है इसीलिए तुम बाहर भाग रहे हो. Equilibrium is life. Chemistry is life. So, as in life, many of the things are situation dependent, condition dependent. In the same manner, when we talk about the life, chemistry, it is condition and situation dependent. It's not yes and no always. Okay. Now, if you change that pressure and temperature condition, a different state of form can become stable. Example, if I take minus 10 degrees Celsius temperature, ice is more stable. Solid water is stable. If I take the temperature between 0 and 100 degrees Celsius, it is liquid water which we have more stable. And if we have the temperature beyond 100 degrees Celsius, then in that case, steam becomes more stable at 1 atmospheric pressure. So you can't even say that solid, liquid, and gas, which one is more stable. You need to know the situation. Is it clear? And here, as you can very well see, even if we have a temperature greater than 100 degrees Celsius, if we increase the pressure, then liquid will become more stable rather than the gaseous form. So it is not that easy to say what is stable. So temperature, pressure, and many other factors change the stable state. Now, if somebody asks you what is the stable state of water, better ask him what is the temperature and pressure. वो कहता है अबे बताना पानी किस फॉर्म में एग्जिस्ट करता है. तो भाई उससे पूछ लो, भाई ऐसा है हम केमिस्ट्री के स्टूडेंट हैं, ये नॉर्मल लाइफ की सिचुएशन नहीं है कि तुम बोलोगे पानी, क्योंकि ये ट्रिक क्वेश्चन हो सकते हैं. पानी किस फॉर्म में स्टेबल है बताओ. बेटा हो कहां पर तुम. अगर एंटार्क्टिका पे बैठे हो या सियाचिन ग्लेशियर पे बैठे हो तो वाटर इन द सॉलिड स्टेट इज स्टेबल. ठीक है. इक्वेटर पे बैठे हो वाटर इन द लिक्विड स्टेट इज स्टेबल. और अगर तुम चांद के ऊपर धूप में रखना चाहते हो पानी को तो वो वेपर स्टेट में ही स्टेबल होगा. So that is what is more important. तो कोई भी आंसर देने से पहले फर्स्ट ऑफ ऑल आस्क व्हाट आर द कंडीशंस. कोई आपसे पूछता है ओए जलेबी खाएगा, सीधा हाँ मत बोल देना. हो सकता है वो जब जलेबी खिलाने से पहले तो मैं ठूस ठूस के खाना खिलाए, करेले खिलाए, खूब पेट भर दे और फिर कहेगा ले 1 किलो जलेबी खा. भाई अभी इतनी खा सकता हूं, सीधी सी बात बोलना, ऐंठ में मत आ जाना, क्योंकि मेनी ऑफ द पीपल वर्क ऑन योर ईगो. ठीक है. So before defining the stability, the condition need to be defined. Now, what is stable? A system. How do we call? Okay, अब conditions वगैरह हमने सब define कर दी. So how do we know the system is stable or not? A system is considered stable when it does not show any tendency to change under a given set of condition. भाई हम तो रजाई में घुस के बैठेंगे, हम बैठे हुए हैं. अगर यही हालत रही तो हम ऐसे ही बैठे रहेंगे. यही हालत रही तो that is the stability. So every system has a tendency to move towards the most stable state. Once at the most stable state, the system stops moving or at least appears to be not moving. ये बहुत इंपॉर्टेंट बात है कि ये जरूरी नहीं है कि आपको दिखे कि हाँ वो नहीं मूव कर रहा है, वो मूव नहीं ही कर रहा है. There is a possibility that some movement is taking place, but you are not able to say that it is moving. So for you, it is stable, it is unmoving. The situation where all the forces acting on the system exactly balance each other. So the net force acting on the system is 0. Net, it is not showing any movement. The system becomes unchanging or apparently unchanging. This becomes the most stable state under the given set of conditions, and this most stable state is termed equilibrium. So are we clear with the what is the meaning of the equilibrium? So as you can very well understand that I'm going to explain each and every term thoroughly. यहाँ पर इस समय मेरे पास 380 slides हैं, 380 slide. Don't try to copy them. If you want to put some important points, go ahead and put it. Okay? I'm going to write a lot in this chapter, but this is the preliminary information. Every system tries to be in the most stable state. In chapter thermodynamics, what we said that the most stable if it has minimum Gibbs energy. So Gibbs energy G is minimum. When G is minimum, then the system delta G becomes zero. That it does not have any tendency to change. It has reached the minimum. Any change would be using the energy. It is going to be zero. Okay. Okay. So when it has minimum Gibbs energy, it means it has minimum capacity to do work. So we can may do it by decreasing the enthalpy or increasing the entropy or a combination of the two. Is it clear? Please take care of your internet connection. Today we have to use a lot. Now let's talk about the equilibrium state. If the system does not show any net change over a period of time, not just an instant, over a period of time, we take an average, it is said to be in equilibrium. Now, net change over a period of time just tells us that even if there are instantaneous changes, small changes taking place at any instant, the system is still in equilibrium if the changes nullify each other. The overall change is zero. Then it is in equilibrium. Now, let's talk about the properties of equilibrium. First of all, equilibrium is a state of system. And most important, equilibrium is not a process. When the system reaches equilibrium, the processes stop. Clear? Equilibrium is a state of system and equilibrium is not a system. I cannot say that this water is equilibrium. Water is at equilibrium. Water is not equilibrium. Okay? My body is equilibrium. My body is not equilibrium. My body is at equilibrium. Okay? So the equilibrium is a state of system and not the system itself. And further, it is not that system at equilibrium cannot be disturbed. Yes, it can be disturbed. You can change the system from the equilibrium, but that will require efforts. And it will try to revert back to the equilibrium. It is something like कि तुम बच्चे को हाथ पकड़ के स्कूल में खींचते हुए लेके जा रहे हो. बच्चा नहीं जाना चाहता तो मैं नहीं जा रहा, मैं नहीं जा रहा, मैं नहीं जा रहा. तुम उसको खींच के लेके जा रहे हो. छोड़ दोगे, भाग जाएगा वापस. वो है इक्विलिब्रियम. वो छोटे बच्चे की तरह है. उसको खींच रहे हो, एफर्ट कर रहे हो, छोड़ते हो, वापस भाग जाएगा. दैट्स व्हाट इक्विलिब्रियम डज. जैसे तुम उसके ऊपर स्ट्रेस या स्ट्रेन हटाओगे, वो वापस अपनी पोजीशन पर आ जाएगा. Is it clear? So that is what we have as equilibrium. It is not the state with zero absolute Gibbs energy. G is not zero. It is the state with lower Gibbs energy than the near states. Let's say हमारे पास ये पहाड़ी रास्ता है, ऐसे 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 ऐसे. Now, if a boulder is lying here, यहां से ये भागेगा नहीं, क्योंकि rest of the two states adjacent to it are of higher energy. So this also is equilibrium. Now, if the rock somehow falls here, this will be at even a more stable equilibrium. So that is what we have as equilibrium. Equilibrium is not just an absolute stability. Equilibrium is relative stability. The other position adjacent to it are higher energy or are more unstable. That is why this state is more stable and becomes the equilibrium. Is it clear? Now let us talk about the different टाइप्स ऑफ इक्विलिब्रियम. हमारे पास बहुत तरह के इक्विलिब्रियम और इक्विलिब्रियम को क्लासिफाई करने के तरीके भी हमारे पास बहुत सारे हैं. So let's talk about the different types of equilibrium. Any problems? शुरू करें? भाई जिसने भी लाइक नहीं किया जल्दी से लाइक कर दो. आई होप आपको कोई फास्ट लगता हो, चलता हो तो नहीं लग रहा ना, कोई बहुत फास्ट तो नहीं जा रहा। डोंट वरी, अगर आपको स्लो लग रहा है तो भी घबराओ मत, कोर्स बहुत आराम से खत्म हो जाएगा, बहुत जल्दी खत्म हो जाएगा। मैं बहुत आराम से पढ़ाऊंगा, बहुत आराम से पढ़ाऊंगा, और आपको यह पता भी नहीं चलेगा कि कब कोर्स खत्म हो गया। एंड यू विल से, अच्छा देखो हमने 3 चैप्टर खत्म कर लिया और मैंने कहीं पर भी फास्ट नहीं पढ़ाया है। आई होप मैंने फास्ट नहीं पढ़ाया है कहीं पर भी, आराम आराम से पढ़ाया है। ठीक, so let's get along with something called the types of equilibrium. What are the different types of equilibrium we have? Now we are going to talk about the type equilibrium on the basis of number of particles involved in the equilibrium. How many particles are involved in it? We can have a single particle system. सिंगल पार्टिकल का मतलब ये नहीं है कि उसमें एक ही एटम है, एक ही मॉलिक्यूल है, एक ही आयन है, एक इलेक्ट्रॉन, एक प्रोटॉन है। नहीं, सिंगल पार्टिकल डजंट मीन दैट वी हैव ओनली वन पार्टिकल इन द सिस्टम. Single particle system is where the entire system moves like a particle. Like, let's say we have this pencil. अब ये पेंसिल मूव करता है तो पूरा का पूरा पेंसिल मूव कर रहा है ना, ऐसा थोड़ी ना कि मैं पेंसिल मूव करता हूं और ये करने भी यहां पे रह गया, ऐसा नहीं होता ना. The pencil is moving completely thoroughly. Is that clear? The pencil is not moving as a different particle. The pencil is moving as one particle. Equilibrium is not the elasticity of the system. Equilibrium is a state where the elastic is most stable. The state in which elastic tries to remain. That is equilibrium. Okay. Now, every system is not flexible. You can disturb the equilibrium. भाई ये रिजिड है, ब्रिटल लगा, मैं इसको तोड़ बेंड करने की कोशिश करूंगा, टूट जाएगी. तो देयर इज नॉट नेसेसरली दैन इलास्टिसिटी. ठीक है. Now we are talking about the different types of equilibrium. Now we can talk about a single particle system. Single particle system का मतलब समझ में आ गया, where the entire system moves like one particle. All the particles move together. There is no independent movement of particles. That is what we call a single particle system. Most often when we talk about equilibrium in physics, we talk about single particle system. Even if we talk about the earth revolving around the sun, it becomes a single particle system because entire earth moves as a particle. So the equilibriums in physics are single particle system, something like the body in a constant state of motion. That body is a single particle. You just put it as a particle. You talk about a bus, you talk about a car, you talk about a boulder, anything, a single particle system. So physics, most often we have a single particle system. So that is the equilibrium. Then we have multi-particle system. Now, multi-particle system does not mean the particle has a lot many atoms, molecules, or ions. No. Multi-particle system is where the particles are moving independent of each other. Clear? But the movement in such a manner that the movements actually cancel each other. If one particle is moving in this direction, another particle is moving in this direction, the net displacement is cancelled out. If a particle is moving up, another is moving down. Maybe one particle moves 2 meters up and two particles move 1 meter each down. So the net displacement becomes zero. So that is what we have as a multi-particle system. And these particles have absolutely nothing to do with each other. They don't even know each other. They don't even say anything to each other. अच्छा तू उधर जा रहा है, मैं इधर जाता हूँ ना, मैं अपनी मर्जी से जा रहा हूँ, तू अपनी मर्जी से जा. But system closed है तो overall equilibrium establish हो जाता है. Clear? So where a large number of particles independent of each other achieve a state where independent movement of particles exactly cancel each other. Nobody wants to do it, but it so happens that it comes out in equilibrium. The people traveling in a bus, which kind of equilibrium you are talking about, Ananya? You are talking about the number of people in a bus. It will somehow attain an equilibrium. Let's say you go in a metro. There will be a situation where the number of people entering the metro and exiting the metro will become the same. कभी ऊपर आता है, कभी नीचे आता है. ठीक है, तो उस तरीके का इक्विलिब्रियम है. A particular number is maintained. Everybody is moving independent of each other. Nobody is thinking, अच्छा तुम यहां उतरोगे, मैं भी यहां उतर जाता हूं. अच्छा तुम वहां से चढ़ोगे, मैं फिर से वहां से चढ़ जाता हूं. Nobody is asking anybody. Is it clear? But if you're talking about people traveling in a bus at a constant speed, you take the bus and the people hold together as one particle. Fine, that is in equilibrium. ये देख लो कि तुम सिस्टम कैसे मान रहे हो, फिर इक्विलिब्रियम की बात करेंगे. Okay, so there is no net change. That is the classification. Now let's talk about the classification on instantaneous position. What exactly happens at an instant? That's what we can talk about. Okay. As far as instantaneous conditions are concerned, there are two types of equilibrium. एक position पे क्या हो रहा है? What changes are taking place? Now, the two types of equilibrium are static and dynamic. Static equilibrium and dynamic equilibrium. Okay, let's understand what is static equilibrium and what is dynamic equilibrium. Static equilibrium is equilibrium where there is no instantaneous change. Now this pencil is lying here, पड़ी हुई है. किसी भी इंस्टेंट पे कोई भी चेंज नहीं आ रहा, तो ये एक स्टैटिक इक्विलिब्रियम है. पहली बात ये ध्यान रखना कि स्टैटिक इक्विलिब्रियम कैन बी अचीव्ड ओनली बाय अ सिंगल पार्टिकल सिस्टम. दैट इज, स्टैटिक इक्विलिब्रियम कैन बी अचीव्ड ओनली इन फिजिक्स. बिकॉज बहुत सारे पार्टिकल होंगे, तो देयर इज नॉट पॉसिबल दैट ऑल द पार्टिकल्स व्हेन दे आर मूविंग इंडिपेंडेंट ऑफ ईच अदर, हाउ कैन दे बी इन अ स्टैटिक इक्विलिब्रियम? If any particle shows any kind of movement, it becomes dynamic. It becomes changing. Overall change is zero. That is why it is at equilibrium. But for an instant, there will be a change. Okay. Priyanshu Ghosh. Sir, like above 100 degrees Celsius in gaseous state, water vapors are stable. They are multi-particle system. Yes, they are multi-particle system. Ankan Banerjee says, sir, can equilibrium be said that the number of bonds break and the number of bonds that form so that we can say the bond is in equilibrium? But a number is not important. Energy, total energy of the bonds. Is the energy being absorbed and energy being released same? When we have water as a liquid state, then in that case, water particles are moving, they are forming the bonds, they are breaking the bond, the number of bonds which are being broken, the energy of the bonds which are being broken, and the energy and the number of bonds which are being formed is the same. So, that is in equilibrium. Is it okay? Prerna Rajput, if you are talking about the number of people on the street at an instant, yes, it is a multi-particle system because all particles, all people are moving independent of each other. And at any given time, the number of particles, number of people on a street is the same. So that's, yes, that's an equilibrium. People moving opposite direction, same direction. भाई ऐसा थोड़ी ना होता है कि एक जगह बिल्कुल खाली हो जाती है, दूसरी जगह में सारे लोग भर जाते हैं. People are moving in all the directions and they are not discussing with each other कि तू इधर जा रहा हो तो मैं इधर जाऊं. Independent. Okay? समझ आ रही है बात? So don't confuse yourself with equilibrium. Equilibrium is wherever the situation is being maintained. एक बाल्टी है, उसके अंदर छेद है, आप पानी डालते जा रहे हो, पानी उसमें से छेद में से निकलता जा रहा है और बाल्टी के अंदर एक फिक्स लेवल ऑफ वाटर इज मेंटेन्ड. That's an equilibrium. Okay? Any system which does not show change over time is at equilibrium. If it is not at equilibrium, it will change. Somehow the things, forces, energies, particles, movements, they balance each other. Whenever there is a balance, it's equilibrium. Okay? But Ankan, equilibrium type depends on number of particles involved. Okay? Equilibrium can be in any situation. Any situation. Understand the definition of equilibrium. Just अपने दिमाग में डालो, when the system does not show a change over a period of time. बात खत्म. उससे ज्यादा नहीं, उससे कम नहीं. No change over a period of time. That's equilibrium. ठीक है? आपका बैंक अकाउंट है, उसमें से आप पैसे विड्रॉ कर रहे हो, डाल रहे हो, विड्रॉ कर रहे हो, डाल रहे हो. Maintaining the constant balance over a period of time. Equilibrium. तुमने पैसे एफडी करा के रख दी, उसमें कुछ पैसे आ नहीं रहे, कुछ जा नहीं रहे. कांस्टेंट. इक्विलिब्रियम. स्टैटिक. है ना? लगता है आपको इस बात में कंफ्यूजन हो रही है कि हाउ वी आर एबल टू सी द इक्विलिब्रियम इन रियल लाइफ. इक्विलिब्रियम तो केमिस्ट्री का कंसेप्ट था, ये रियल लाइफ में कैसे आ गया? लोगों के जाने में आने में इक्विलिब्रियम कैसे आ गया? खाने पीने और सोने में कैसे इक्विलिब्रियम आ गया? इस बात का प्रॉब्लम आ रही है क्या? नहीं, Anoop sir, lecture duration is not in equilibrium, it is fluctuating. Okay, and every day we are having lectures, the number of lectures are increasing. That is not equilibrium. No, that is not equilibrium. Okay, but हाँ, number of students is in equilibrium. देखो 11 बच्चे watching है, वो 11 ही है। एक छोड़ के चला गया, एक ने ज्वाइन कर लिया, दो छोड़ के चले गए, दो ने ज्वाइन कर लिया, वो इक्विलिब्रियम है। अनचेंजिंग ओवर द पीरियड ऑफ टाइम, ये इक्विलिब्रियम है। नंबर ऑफ स्टूडेंट्स वाचिंग द लेक्चर, ठीक है, कभी ऊपर चला जाता है 14, कभी 7 चला जाता है एवरेज, फिर वही 11 रह जाता है। इज इट क्लियर? अब ये तो सारे के सारे अपनी हंसी वाले चेहरे लगा रहे हैं, सबके सेम, ये इक्विलिब्रियम हो गया। एनीवे, लेट्स कम ऑन टू द स्टडी, ठीक है। Now let's talk about the static equilibrium. So we have just talked about the single points. Body at rest, body with uniform motion. Okay, this is the equilibrium. Now let's talk about the dynamic equilibrium. Now dynamic equilibrium could be a single particle system. An important thing is a multi-particle system can never be a static equilibrium. Okay, like static equilibrium is always single particle. Okay, fine. Multi-particle system can never be static. अब मेरी स्टेटमेंट सुन लेना। Static equilibrium is always single particle. Okay. Dynamic equilibrium can be single particle, can be multi-particle. Let us say we have a pendulum which is hanging, not moving at all. Single particle, static equilibrium. Oscillate it. Again in equilibrium, net displacement zero. A single particle, dynamic equilibrium. Okay. Then a multi-particle system is always dynamic. अलग अलग पार्टिकल मूव कर रहे हैं, इक्विलिब्रियम है, रुके हुए हो गए तो वो सिंगल पार्टिकल मान लिया जाएगा, क्योंकि ऑल पार्टिकल्स आर at the same position relative to each other. System moves together. A multi-particle system where the particles are moving independent of each other can never be static. It has to be dynamic. नहीं तीर्थराज, इक्विलिब्रियम में तो आप तभी आते हैं जब आप जा चुके होते हैं। होम्योस्टैसिस, बायोलॉजी में टर्म होती है ना, होम्योस्टैसिस। Our body is working every time to maintain or prevent equilibrium. हम जो रोज एफर्ट्स करते हैं ना, वो इक्विलिब्रियम को प्रिवेंट करने के लिए करते हैं। वी आर नॉट मूविंग, वी आर एक्चुअली मूविंग टुवर्ड्स आवर मोर स्टेबल स्टेट, but we are preventing it as far as possible. And for that, we are spending energy at every instant. Yes, SHM is a dynamic equilibrium. Is that clear? So dynamic equilibrium is an equilibrium where there is a continuous change such that the net change becomes zero. The change is continuously taking place, but it is continuously balanced by other changes. The equilibrium in which there is instantaneous changes, but overall there is no change over a period of time. Oscillating pendulum, dynamic equilibrium. SHM, dynamic equilibrium. Okay. Static pendulum is a static equilibrium, single particle system. If now it is oscillated, there would be a change at every instant, but the overall change over a period of zero. So it becomes dynamic equilibrium also. Now we talk about the equilibrium on the basis of the relation with the surrounding, how the system interacts with the surrounding. Okay. अच्छा, एक बात का ध्यान रखना, equilibrium is maintained always in a closed system. Open system equilibrium नहीं होता. On the basis of the relation with the surrounding, we have physical equilibrium. Physical equilibrium, in which the constitution and the nature of particles involved in equilibrium has nothing to do with the equilibrium. I have 10 particles. वो कंचे हैं, आदमी हैं, balls हैं. Doesn't make a difference. Okay. If the overall force acting on the system is balanced, the system is considered to be in equilibrium. Like you have a point mass. A point mass में iron है, gold है, silver है, platinum है. Doesn't make a difference. ठीक है, आपने एक बॉल ले ली ऑफ द मास 1 kg, किसी की भी ले लो कोई फर्क नहीं पड़ता, गोल्ड की ले लो, प्लैटिनम की ले लो, क्या फर्क पड़ता है? Is it okay? If the overall force acting on the system is balanced, the system is considered to be in equilibrium. That's physical equilibrium. Examples are a lot many. A body moving with uniform velocity, a body at rest, a body. What is the constitution of the body? I'm not bothered. Clear? A body in a uniform circular motion, an oscillating pendulum. The physical equilibrium are generally one particle system. Generally. Okay. Maybe multi-particle system also. Physical equilibrium could be static or dynamic. Clear? Physical equilibrium could be anything. Now then we have chemical equilibrium. Now if the consideration is not the position of the entire system with respect to the surrounding, but the position of the particles constituting the system. Okay. And we need to know what the particles are, what their chemical nature is. That is the chemical system, and equilibrium achieved in this system is called a chemical equilibrium. And it is always a multi-particle dynamic equilibrium. Chemical equilibrium कभी भी static equilibrium नहीं होता. This makes it a dynamic equilibrium as all particles involved in a chemical equilibrium cannot come at rest at the same time. They all will be moving. What has happened to my hand? Nothing has happened to my hand, beta. It is artist's glove. वो मेरे पेन टैबलेट के ऊपर, मेरे आईपैड के ऊपर निशान पड़ जाता है ना, इसलिए. सायन साहा, इज दैट ओके? मैं सोच रहा था इतने दिन से किसी ने पूछा क्यों नहीं. पूछ ही लिया. गुड, थैंक यू. ओके, काला काला बिल्कुल. वैसे सोच रहा था एक ग्रीन कलर का ले लेता, ग्रीन कलर का ले लेता, ये गायब भी हो जाता, दिखता ही नहीं. ओके, सो दैट्स व्हाट वी अंडरस्टूड द केमिकल इक्विलिब्रियम. किसी को यहां तक कोई बात पूछनी है? So chemical equilibrium is a dynamic equilibrium. I have just explained it. So when chemical equilibrium is considered, we always have multi-particle system, and if we have multi-particle system, it is always dynamic equilibrium. Any confusions? Okay. So when we talk about chemistry, the number of particles is always greater than the overall population of world. यार एक सीधी सी बात है. 6.022 into 10 raised to power 23 is 6 lakh billion. Okay, 6 lakh billion. What is the population of the world? 6 or 7 billion. तो lakh billion तो रह ही जाएगा. So whenever we talk about the particles in chemistry, it is always greater than the population of world. And so it cannot be a static equilibrium. These particles are moving independent of each other. So chemical equilibrium is always dynamic. Now let's classify on the basis of phase. Okay? And whoever has not liked the session, go ahead and like the session. समझ में आ रहा है ना सबको? किसी को कोई confusion? Let's understand what is the meaning of the word phase. Phase क्या होता है? Phase is the part of the system having a definite boundary within which the various properties such as temperature, refractive index, composition, density remain the same. That is, the different constituent particles cannot be distinguished. We can say all intrinsic properties remain a constant. So then we consider it to be the same phase. Okay, we are not able to individually distinguish between the particles. We are not able to see the particles constituting the system. तो इसे हम बोलते हैं सिंगल फेज सिस्टम. Okay, any confusions? It is a continuous part of the system without any visible break, and that's very important. No visible break is there. Okay, जब states different होती हैं तो phase तो different होगा ही होगा. Solid and liquid, they are different phases. Liquid and gas are different phases. Solid and gas are different phase. Liquid, solid, and gas are different phase. But there is a possibility when the states are same, but phases are different. Something like, let us say we talk about water and benzene system. Both are colorless, immiscible liquids. Water has a higher density, so benzene would form the upper layer, water forming the lower layer, and both have different refractive index. दोनों के बीच में एक boundary clear नजर आती है. पानी के अंदर एक drop oil डाल के देख लो. You will be able to see the oil drop clearly, and that's a two-phase system, although both are liquids. Is it clear? जिसने भी अभी तक like नहीं किया, like करो भाई. We are stuck on to 20 likes. Where are the other likes? Is it clear? So that becomes a two-phase system. Okay. On the basis of the phase, we have something called homogeneous equilibrium and heterogeneous equilibrium. Okay. Homogeneous equilibrium, the equilibrium in which all components, including the reactant, product, catalyst, solvent, solute, everything is in the same phase. That is what we call as homogeneous equilibrium or one phase equilibrium. Now you need to remember one thing. Homogeneous equilibrium is possible only in two cases. Only in two cases. First one, all components are gases. If all components are gases, then in that case it becomes a homogeneous equilibrium. Okay? And second, all components are dissolved in the same solvent. Okay, that is a solution. If any equilibrium involves any solid is involved, it is heterogeneous. Equilibrium involving solids are always heterogeneous. Is it clear? So that is what we have as the heterogeneous equilibrium. The equilibrium involving solids are always heterogeneous. They are never homogeneous equilibrium. Okay. So the equilibrium in which any of the component is present in a phase different from any other component. So there are two components which are in different phases. Enough. It's a heterogeneous equilibrium. Clear? Now let's talk about the relation between reactants and products. How are reactants and products different from each other? Obviously, there are differences. That is why they are reactants and products. If there is no difference, then in that case, there won't be any reactant and product. There won't be an equilibrium. And the relation between the reactants product, this is one thing called phase equilibrium. Now, many of the books, many of the places, even NCRT, refers to phase equilibrium as physical equilibrium. But that's not physical equilibrium because they have defined this phase equilibrium under chemical equilibrium. Now, why do they call it physical equilibrium? Because they say that the physical state of the substance is changing. The chemical nature does not change. And when the physical state of the substance changes, its phase actually changes. So I prefer to call it phase equilibrium. Okay. So I prefer to refer to as phase equilibrium. And quite obviously, phase equilibrium is heterogeneous. There will be always at least two phases. And there are so many kinds of phase equilibrium. The equilibrium in which the components on the left and the right side of the equation differ only in phase. Only in phase means only in physical state. Chemically, they are exactly the same. Something like we have iodine in the vapor phase, in the solid phase, water in the liquid phase, solid phase, gaseous phase. That is what we have as phase. They have the same chemical property but different physical property. No confusions here? Okay. Noting it down, understanding it thoroughly. And then we have the non-phase equilibrium, which I prefer to typically call chemical equilibrium. Okay. When say phase equilibrium or chemical equilibrium, they are the part of chemical equilibrium only because change of phase also is a chemical process. Chemical equilibrium is the equilibrium in which the components on the left hand, the right hand side of the equation may not differ in the phase. Maybe they have the same phase. They may have different phases as well. Okay. But they differ in chemical properties. Okay. Left and right hand side are different chemical species. So that is what we have as a non-phase equilibrium or the chemical equilibrium. Okay. Now we are going to talk about a very peculiar equilibrium which was earlier in NCRT, but now it is not. Partition equilibrium. Let's say we have a container, and in this container we have carbon disulfide. This is carbon disulfide. Okay. And in addition to carbon disulfide, here we have water. Now, carbon disulfide has a higher density than water, so carbon disulfide is going to be at the base and water is going to be on top of it. Now, what I do is I put some iodine in it. I put some iodine in it. So if I place some iodine in it, then in that case I will find that some of the iodine dissolves in carbon disulfide and some of the iodine dissolves in water. Now you need to remember that iodine is a non-polar substance, and being a non-polar substance, the iodine is going to dissolve more in carbon disulfide and less in water. Okay. Now there will be an equilibrium which is established between aqueous and non-aqueous layer. Yani ki we have an equilibrium between aqueous iodine and we are going to have an equilibrium with iodine in carbon disulfide. Now this actually becomes a phase equilibrium because these are two phases. Is that clear? And you will be able to see a demarcation between them. They have the different refractory index. Is this clear? The carbon disulfide layer is going to become deep violet and water layer is going to get tinge of violet. The two layers are in contact with each other. The iodine molecules from water layer continuously move to the carbon disulfide layer while the molecule from the carbon disulfide layer move towards water. Is that okay? Is it okay? So there is a dynamic equilibrium established between the number of iodine molecules in water and carbon dioxide layer. The concentration becomes unchanging and each layer is a constant. Now we can talk about the ratio of the concentration in the water layer and carbon disulfide layer. And that ratio is called partition coefficient. It's the ratio of the concentration of a compound in two phases of a mixture of two immiscible liquids at equilibrium. So it is two immiscible liquids. So we have two different solvent with a common solute. Two immiscible solvents with a common solute. So we are talking about distribution of a solute in two different solvents. Clear? So that is what we have as a partition coefficient. Most often, one of the solvent is aqueous, other one is hydrophobic, such as one octanol, benzene, carbon disulfide, carbon tetrachloride. Now, this is constant for a given set of solvents at a constant temperature. If you change the temperature, then in that case also it is going to change. Now, this is the principle behind the solvent extraction. Solvent extraction is being used. Yes, Mayuk Sen Gupta, we can clearly distinguish between these two liquids in this equilibrium because they are in different phases. Who says that equilibrium you cannot distinguish between the components? Who says that? You can. The only thing is the two components are unchanging. That is equilibrium. Equilibrium has nothing to do with how many components are there, how many particles are there. The equilibrium is only a state where the system becomes unchanging. Clear? Fine. So this is what we have as solvent extraction. Many of the perfumes are made by this solvent extraction method. Many of the things are created by solvent extraction method. So this is a very important universal method which is being used in many of the industries. Okay. So let's see this question. The distribution coefficient of iodine in CS2 with respect to water is 600. यानी कि concentration of I2 in carbon disulfide divided by the concentration of iodine in water is equal to 600. Now, this is a dimensionless quantity because the numerator and denominator have the same units. It is a concentration unit. Okay. If the concentration of iodine in carbon disulfide in contact with water is 2.1 gram per centimeter cube, what is the concentration of iodine in water? Can you just simply solve it? You have already got the concentration in numerator. You just need to give the concentration in denominator. Answer, jaldi se answer do. Substitute and answer. Anybody who has not liked the session, go ahead and like it. सॉल्व करो भाई, आंसर दो. पेपर पेन है ना आपके पास? इजी ना? Simple answer, simple question. Clear? So when we talk about the states of matter, now we are going to talk about some more about the phase equilibrium. Before that, we need to know about the states of matter. Now, this is what we have already done when we were talking about the solid state and the gaseous state, that there are two opposing forces acting in the substance which decide the state of matter. These two forces are attractive forces between the particles, the thermal energy. Okay. The attractive forces try to get the particles near to each other and hold them in a place. The thermal motion acts opposite to these attractive forces and makes the particles move away from each other. Remember? The attractive forces are maximum at a specific distance. Increase or decrease in distance would reduce these forces drastically. Okay, the attractive forces have a maximum limit. You cannot make it more than that. ऐसा नहीं किसी को जकड़ के दियो आप उससे प्यार बढ़ा दोगे, हो सकता है तुम जकड़ो और वो भाग जाए. ठीक है, वो एक हिंदी में गाना था ना, यूं हसरतों की राह में मजबूर हो गए, इतने हुए करीब कि फिर दूर हो गए. So too close also may be the reason of increasing distances. ठीक है ना? So attractive forces have a maximum limit. When we talk about thermal motion, it is temperature. The increase in temperature would increase the thermal motion. The lowest temperature is 0 Kelvin, where all the motion cease, and even slight attractive forces will be able to force the particles together. Now, there is no limit to the temperature increase, and that is why the temperature can always overcome the attractive forces. Clear? The temperature at which the attractive forces are completely overcome by thermal motion so that you cannot solidify a substance or liquefy a substance, whatever be the pressure, is termed as critical temperature. Is this clear? So that is what we term as the critical temperature. Fine? जिस किसी ने लाइक नहीं किया जल्दी से लाइक कर दो. Now, solid is a state in which the attractive forces between the particles is so high that the particles cannot show any motion other than the vibrational motion at their mean position. बैठे बैठे हिल रहे हो. अब आप क्लास में बैठे हो, टीचर बहुत स्ट्रिक्ट है, ऐसे ऐसे हिले जा रहे हो. क्लास के अंदर बैठे हुए हिल रहे हो. बस इससे ज्यादा आप नहीं हिल सकते क्योंकि टीचर ने पकड़ के पीट देना है. So that is what we have as the solid state where the particles cannot show any other motion other than the vibrational motion at their mean position. Mayuk Sen Gupta, equilibrium, thermodynamics, kinetics, they are the sum of all chapters. और शायद इसीलिए इक्विलिब्रियम इतना डिफिकल्ट भी है कि अगर आपको गैसियस स्टेट नहीं आता, सॉलिड स्टेट नहीं आता, केमिकल काइनेटिक्स नहीं आता, थर्मोडायनेमिक्स नहीं आता, तो इक्विलिब्रियम भी नहीं आएगा. ठीक है ना? बट स्टिल इट्स नॉट दैट डिफिकल्ट. इतना मुश्किल भी नहीं है. Okay? The position of the particles related to each other and the average distance remains a constant, hence they cannot move relative to each other. The shape is fixed. And since the average distance does not change, the volume is fixed. So the solids have a constant volume and a constant shape. Solids can have any number of free surface. That is the most important thing. Solid की आप कोई भी शेप बना सकते हो, कितने भी surfaces हो सकते हैं. Now, liquid is kind of a transitory state from the solid to the liquid. Solids, the attractive forces completely overcome. In the gases, the thermal motion completely overcome. In liquid, they are somewhat at equilibrium, somewhat balancing each other. The liquids are the substance in which the attractive force keep the particle at a constant average distance from each other, but the thermal motion is able to move the particles relative to each other. The attractive forces between the constant particles, in case of liquid, most often it's the molecules, are such that they allow only the rotational and vibrational motion. Is that clear? Fine. Now that rotational motion is responsible for the fluidity of the liquids. Shape will change according to the container. It can have a maximum free surface. One free surface. Okay. Liquids का एक free surface होता है. Otherwise, it's going to be a spherical structure. That also is one surface. Or if you are put it in a container, then in that case, the top surface would be the free surface. Is it okay? It has a constant volume. When the thermal energy completely overcomes the attractive force between the particles so that the particles move independent of each other, the substance becomes a gas. Their position relative to each other changes and they do not have any definite shape. The particles keep moving till they encounters an obstacle, which could be another molecule. That is, in the case of gases, the particle will keep on moving in a straight line until unless it gets an obstruction, and from that an obstruction it can deviate. Okay. So in case of gases, the particles just keep on moving straight. टकराया इधर चला गया, दीवार से टकराया, किसी और से टकराया, आंख बंद करके, इट्स समथिंग लाइक यू हैव क्लोज योर आईज, यू आर मूविंग स्ट्रेट, टकरा गए, घूम गए, फिर निकल गए, फिर टकरा गए, फिर घूम गए, निकल गए. It's like that. So that is what we have as the gaseous state. Since they are moving in a straight line, if they happen to be moving towards the open state, it's going to keep on moving till it moves to the out of the universe. Okay. So gases, they occupy the entire place, space available to them. They occupy the entire container. They take the shape of the container. They take the volume of the container. Okay. Is this clear? Any confusions here? No problem? Now let's talk about something called the vapor. वेपर क्या होता है? ठीक है, एक काम करते हैं. लेट्स हैव अ 3 मिनट ब्रेक. 3 मिनट का ब्रेक. So when do we meet? It's 12, 11, 16. Start again at 11:20. पानी वानी पी के आ जाओ, जल्दी करो. Okay, welcome back. Break over. Now let's talk about what exactly is the meaning of vapor and how it differs from a true gas. Okay. If the particles are moved far enough from each other, the attractive force between them drastically reduced due to the increase in distance. I told you that the attractive forces depend on two factors. One, the nature of the substance and the distance between the particles. So if you increase the distance between the particles, then in that case, the particles are going to move far away. The attractive forces are going to decrease because the attractive forces, they depend on inverse of the square of distance. Okay. Now the particles move absolutely free of each other, just like a gas. Is this clear? Now, if the particles are forced to come close to each other, again the attractive force will be able to overcome the thermal motion and the substance will liquefy. Clear? So that substance is termed as a vapor. Clear? A gaseous substance that can be liquefied by increasing the pressure while keeping the temperature constant is termed, or you may simply can say a gaseous substance below the critical temperature. That is what we termed as a vapor. So it is a gaseous substance below the critical temperature. That is what we call as a vapor. So I hope you understand what is a vapor. Now let's talk about the liquid in a container. Now this is what we are having a liquid state definition also. Liquid state we have talked, we didn't do it in states of matter. So here we are doing the liquid state as well. A molecule in a bulk can experience two kind of forces. One is called the cohesive force, other one is called the adhesive force. What is the cohesive force? Cohesive forces are the attractive forces between the molecules of the same kind. Let's say we have talked about the water, then water molecule. Attractive forces are going to be termed as the cohesive forces. Adhesive forces, these are the attractive forces between the particles of different type, like water and the container. So that is what we have as adhesive forces. Okay. Now, a liquid in a container has three kind of molecules, three kind of attractive forces on the basis of attractive forces. तीन तरह के attractive forces हैं उसके अंदर. Now, what are those three types of molecules? One in the bulk. Okay, this is the container, this is the liquid, and I'm talking about the molecule here. So this is the molecule in the bulk. Okay, now it is attracted by the same kind of molecule from all sides. These are cohesive forces. Higher is the attractive force felt by the particle, lower is its energy. So this is somewhat I can say the least energy particle. Yes, Mayuk, we are going to talk about the wetting of the substance by the liquid, but at this moment we have started from the molecule in the bulk. Now, this molecule in the bulk is not wetting anything. It is attracted by, from all sides by the same kind of molecules, same type of molecules. ओके, मैं अभी तक 23 लाइक्स पे क्यों अटका हुआ हूं? सबने लाइक कर दिया ना जितने हैं? ओके, द नेक्स्ट वन इज द पार्टिकल नियर द वॉल ऑफ द कंटेनर, मतलब कि ये वाला पार्टिकल। जब इस पार्टिकल की बात करते हैं तो इसको दो अट्रैक्टिव फोर्सेस मिल रहे हैं, वन फ्रॉम द लिक्विड दैट इज द मॉलिक्यूल्स ऑफ द सेम काइंड एंड अदर फ्रॉम द वॉल ऑफ द कंटेनर, यानी कि इस पे एडेसिव और कोएसिव फोर्सेस दोनों वर्क कर रहे हैं। ओके, now it has two types of forces acting on it. One on one side, it's attracted by the molecules of its own kind, that is the cohesive forces. And on the other side, it is attracted by the particles of the wall of the container, and that is adhesive forces. So there are adhesive forces and there are cohesive forces. And the important thing is these two kind of forces are not identical most of the time. They are not identical most of the time. ठीक है ना? So these forces do not balance each other. Now let us see what happens if we have these forces non-balancing each other. If the cohesive forces are stronger than the adhesive forces, the molecule near the wall will experience an unbalanced force towards the bulk. It will try to move towards the bulk away from the wall of the container. So what we'll find is that if we have the narrow container like this, the liquid will form this kind of a surface. This is what we call as a convex surface. Okay? The liquid is moving away from the wall of the container. ठीक है? Now, this is something like mercury in what? Mercury in a glass container. Maybe you have seen the thermometer. Thermometer, the mercury forms this kind of a layer. Okay. Now, such kind of a liquid will not stick to the surface of the container. This will be a non-wetting liquid. This is a non-wetting liquid. If the liquid is drained out, it will not leave any trace in the container. Such a liquid does not wet the surface. The case is mercury in a glass container, water in a Teflon coated container, or water in a container coated with oil. So this kind of the force would be seen there. Now we can have the adhesive forces stronger than the cohesive forces. The example could be the molecule near the wall will experience an unbalanced force towards the wall of the container. And in such a case, the liquid, since it's going to be attracted towards the wall, it is going to move like this, more towards the wall. And this is what we have as the concave surface. This is concave. Is this clear? Mercury in a steel glass. Well, I have not checked it. You may check it and then see it. I won't predict anything. But I know one thing that water in a silver container is a flat surface. Water in a silver container shows a flat surface. So that could be an identification of silver articles. Clear? What happened, Teethraj? Buffering हो रही है क्या? Now, liquid which has more of adhesive forces will have a tendency to stick to the surface. Now, this becomes a wetting liquid. Fine. If we are talking about water and we are not talking about specific cases, then most often water, the cohesive forces dominate over the adhesive forces dominate over cohesive forces. And so, water is wet. Why is water wet? The reason of water being wet is the dominance of adhesive forces over cohesive forces. Clear? वाटर इन अ सिल्वर कंटेनर इज अ peculiar एग्जांपल जहां पे कोहेसिव और एडिसिव फोर्स एक दूसरे को बैलेंस कर लेते हैं. ओके, वेदर खराब है आपके यहाँ पे तीर्थराज. ओके ओके ओके. ओके, now the molecule on the surface of the liquid. So we have talked about the bulk, we have talked about the wall of the container, and now we are going to talk about the molecule on the surface of the liquid. Now, liquid molecules below the surface and gas above the surface. So here we have the container. This is the surface, and this is the molecule on the surface. Here it is being attracted by the molecules below the surface, on the surface, but here on the surface it's going to be gas. So the attractive force proven given by the gas is negligible. So it suffers a net force in the downward direction. So there is a net force acting in the downward direction, which is trying to pull the molecule from the surface inside. Is it clear? अच्छा, आज 8 बजे हमारी स्पेशल क्लास होगी एंड वी आर गोइंग टू टॉक अबाउट द क्वेश्चंस ऑफ द चैप्टर कॉल्ड metallurgy. Is this clear? ओके, मजा आएगा, बिल्कुल आएगा मजा. Now this molecule has a tendency to move towards the bulk. The molecule in the bulk do not allow the surface molecule to enter. भाई वो अंदर आना चाहता है, अंदर वाले मॉलिक्यूल आने नहीं दे रहे, तो दरवाजे पर भीड़ हो जाती है. ठीक है, दरवाजे पर भीड़ हो जाती है, दरवाजे पे एक एक्सेस एनर्जी आ जाती है. And this excess energy on the door lead to an excess crowding on the gate, and this same manner, this creates a tension on the surface, and there is called surface tension. So there is a crowding of the molecule on the surface causing the surface tension. Is it clear? Now, this extra energy per unit area or extra force per unit length acting on the molecules on the surface due to the difference in energy between the molecules on the surface and the molecules in the bulk, इसे कहते हैं surface tension. Is it clear? So surface tension by definition is the extra energy acting on the surface of the bulk. surface of the liquid, and or you can say that it is extra force per unit length. The units are going to turn out to be the same. That is what we call a surface tension. Now, the molecules on the surface have higher energy, and every system wants to have a lower energy. So, every system wants to have the least surface. You need to know that for any given volume, sphere has the least surface area. And that is the reason why the liquid drops are spherical in structure. And that is the reason why the sphere is the most dominant shape in the universe, because it has the least surface area, the least energy. Is it clear? So that is the reason why we have sphere as the structure. Fine. Now, due to the surface tension, a small mass can float on the surface even if the particle is much dense than the liquid. Okay. I believe I'll be able to show you certain things. Here you can see. Can you see that? A pin floating on the surface of water. This pin is floating on the surface of water because of this surface tension. Is it very? सर आप नीट 2024 की लाइव क्लास कब लेते हो? हंसिका चल रही है बेटा नीट 2024 की लाइव क्लास. देखा ये? And then you would have seen this. अभी देखा है? मच्छर पानी पे बैठा हुआ. ये जो मच्छर पानी पे बैठा होता है ना, this is because of not necessarily you coat it with oil. You can make the pin float on surface of water without coating it with oil. This is water strider sitting on the surface of water without oil. ठीक है ना? Now this is because of surface tension. This is due to surface tension. Is it clear? So that is what we have as different kind of attractive forces in the liquid. Here you can see the meniscus, the upper and the lower meniscus. Any kind of doubts? नहीं बेटा, वुड के फ्लोटिंग में सरफेस टेंशन का कंसेप्ट नहीं है, वुड के फ्लोटिंग में डेंसिटी का कंसेप्ट है, दैट वुड हैज अ लोअर डेंसिटी एज कंपेयर टू वाटर. सो द वाटर मास डिस्प्लेस्ड is greater than the mass of the wood, which makes wood float on the surface of water. Okay? That is not surface tension. Surface tension is working where the density of the floating particle is more than the density of water. तब हम बात करते हैं इसकी. Is that clear? Now the surface molecule has a higher energy, the rest of the bulk molecule have an average kinetic energy. Now the average kinetic energy is temperature dependent. The surface molecule has a higher potential energy due to less attractive forces. And now that is very much clear. Lesser are the attractive forces, more would be the energy. Okay. The bulk molecules are in a constant state of random motion. This motion is due to slight temperature fluctuation within the bulk. They keep, and this is what we call as the Brownian motion. This is responsible for the Brownian motion. Now, if a low mass particle is suspended in the bulk, it will show a constant random motion. That constant random motion is termed as the Brownian motion. Clear? The bulk molecules, they collide with each other, exchange the kinetic energy, and they may strike the surface molecule, providing it an extra energy. Now, if they provide an extra energy to the surface particle, it is possible that that surface particle may gain the energy enough to move out from the bulk. Okay, and then it may move to the vapor phase. So when it moves to the vapor phase, it is termed as vaporization. The conversion of the liquid to the vapor is termed vaporization. Now it is an endothermic process. Vaporization is an endothermic process. Conversion from the liquid to the gaseous state is endothermic process, and it requires latent. Latent का मतलब क्या होता है? Hidden. Latent is the hidden, which is not visible, which is not seen in the change in temperature. So that is what we have as the latent heat of vaporization. Is it clear? The hidden heat of vaporization. So the movement of molecules from the surface of the liquid to the vapor phase is termed evaporation. So are we clear about what is evaporation? It is the vaporization of the surface molecule. Vaporization is the big part, of which evaporation is one type. Clear? The molecule on the surface had the highest energy. It takes an extra energy from the bulk and moves out. Now, it is something like a class as the highest marks holder, and you take out that person. If you take out that person, the average marks of the class are going to decrease. That is, the evaporation, vaporization causes the average kinetic energy of the bulk to decrease. And average kinetic energy is temperature. So इसका सीधा सीधा मतलब ये हुआ कि evaporation will cause the temperature to decrease. And temperature to decrease का मतलब है cooling. यहां पे सीधी सी बात आ जाती है स्टेटमेंट evaporation causes cooling. Is that clear? So evaporation causes cooling. Any confusions here? कि evaporation से ठंडा क्यों होता है? Why does evaporation cause cooling? Read through it. Any kind of problems, anybody? Now, if the system is insulated or evaporation is rapid so that it's not able to gain heat from the surrounding, the system would be cooled. So this is the principle of evaporative cooling. हमारे air coolers जो होते हैं ना, desert coolers, वो इस principle पे work करते हैं, evaporative cooling. Now, evaporation किस किस चीज पर depend करता है? It will depend on the surface area. More is the surface area, more are the molecules on the surface. More would be the tendency to evaporate. So simply the larger the surface area, more the molecules on the surface, and more would be the amount of evaporation. जब आप कपड़े सुखाते हो तो उनको फैला देते हो. क्यों फैला देते हो? To increase the surface area. Clear? And if you just put them in a bulk, then in that case the clothes will take much of the time to evaporate to dry. And then not only they are going to take more time to dry, they are also going to take like it might become smelly also, isn't it? Maybe inside they remained wet and surface they become dry. Okay. A given amount of water spread on a large surface area would evaporate much faster, while in a narrow container would take a very long time to evaporate completely. Is this clear? Then obviously rate of evaporation, that time taken for evaporation is going to depend on the nature of the substance. A substance which has lower boiling point, that is which the attractive forces between the molecules are that is going to be lower. If the attractive forces are higher, then in that case the substance is going to take more time to evaporate. It would need much higher energy to move into the vapor phase. So the amount of evaporation at a given time would be much lower since the attractive forces are higher, the nature of the substance. And if the substance has less attractive forces, it is going to have a higher vapor pressure, it's going to have a lower boiling point, and it will evaporate much faster. Is this clear? So as the temperature increases, the average kinetic energy of the bulk increases. If you increase the temperature, evaporation. This increases the tendency of the transfer of energy to the surface molecule and increases evaporation. So vaporization increases with temperature. Okay. Vaporization increases with increase in temperature. Any confusions here? Time. कपड़े सूखने में देर लगती है. ऐसा नहीं कि आपने डाले और सूख गए. It takes some time to evaporate. It's not instantaneous. Evaporation is not instantaneous. Now we talk about something called the rate of evaporation. Now, rate of evaporation is the amount of evaporation per unit area per unit time. So it becomes independent of the time, it becomes independent of the area. Now it depends only on two factors. One is nature and other one is temperature. Clear? Other than that, you change anything, the rate of evaporation does not change. Got it? This is the word called rate of evaporation. Any confusions? Now, if I put it in a closed container, they will not be able to move out. They will form an equilibrium. And then the vapors will start exerting a pressure on the wall of the container and the surface of the liquid. Here is the liquid. Here is the vapors. The vapor are going to strike the wall of the container, the surface of the liquid, the lid, and there will be a pressure generated by the vapors. Okay. As we increase the concentration, the exerted pressure also increases as the vapors increase. Now, there is a possibility that they might transfer the energy to the container or something and they condense. So here it's going to be evaporation. Will try to come in equilibrium with condensation. Okay. Okay. When evaporation comes in equilibrium with condensation, then there is an equilibrium which is established where the vapor pressure of the vapor becomes a constant. So the concentration of the vapors become a constant, its vapor pressure becomes a constant. Okay. As the concentration, that is the pressure of the vapors increases, the rate of condensation increases. So while the rate of evaporation is a constant, because it depends on only the nature and temperature, at certain time the rate of condensation will balance the rate of evaporation. Okay, rate of condensation will balance the rate of evaporation. At that time, the equilibrium will be established. It will remain the equilibrium. The concentration of vapors and the pressure exerted time will become a constant. It's a dynamic equilibrium. It's a dynamic equilibrium. Okay. Net change becomes zero. The pressure exerted by the vapors of a substance on the surface of the substance and the walls of the container in a closed container at a constant temperature at equilibrium is termed vapor pressure. So please understand vapor pressure is at equilibrium. Please understand vapor pressure and pressure of the vapor are two things. Pressure of the vapor becomes equal to the vapor pressure at equilibrium. Got it? Absolutely clear? Anybody who has not liked the session, go ahead and like it. Now, if we keep on changing the pressure and the volume, remember, if you increase the pressure, the rate of condensation would increase. Pressure initially would increase. Initially. But then the rate of condensation is higher, it will keep on decreasing the pressure, and ultimately the vapor pressure is going to become, pressure of the vapor will become equal to the vapor pressure again. Fine. So after some time, it is going to again come at equilibrium. Please remember, you can change the pressure for some time. You can disturb the equilibrium for some time, but the equilibrium will be again established. Is it clear? Now, if you move the piston upwards, you are going to decrease the the pressure of the vapor. The rate of evaporation remains the same, rate of condensation decreases. So slowly the pressure will again increase, and again it is going to become the same. So change in pressure is not going to change the vapor pressure, and equilibrium will be again established after certain time. Okay? Fine. So here again it is going to be established. So vapor pressure does not depend on the pressure applied on the system. It is going to be, the pressure of the vapor can be changed for some time, but it is again going to reach the vapor pressure. Is it clear? The pressure of the vapor can change, but the vapor pressure is a constant. Now let's talk about the temperature. If you increase the temperature, you increase actually the rate of vaporization. Fine. Rate of concentration would increase, increasing the rate of condensation, and again the equilibrium will be established. But now the vapor pressure would be increased. So vapor pressure increases with temperature. And we have even talked about it in the Clausius-Clapeyron equation, the solution chapter. Remember solution chapter? If you're not, then in that case, I would suggest that you go ahead and watch the videos of solution chapter. So vapor pressure depends on the same factors as the rate of evaporation, that is the nature of the substance and temperature. If you change anything else, vapor pressure is not going to change. And nature of the substance is also the composition. Is this clear? Any other change is not going to change the rate of vaporization. The vapor pressure is the measure of escaping tendency of the molecules from the surface of the liquid. Hence, whenever we like to talk about escaping tendency, we talk about vapor pressure. More the vapor pressure, more easily the molecules are escaping. Less is the attractive forces between the molecules, more volatile is the substance, and so on and so forth. Fine. Now let's talk about an open container and keep on increasing the temperature of the system. Now what happens? Open container. Okay. Now here what happens is, here we have increasing the temperature. This is the liquid and the container is open. The molecules are trying to escape out. Now the molecule of the gas will strike it and try to resist its movement. The molecules of the gas on the surface will try to resist its movement. Now, gas molecule that is going to create the external pressure. So the molecule escaping from the container will have to have a little higher energy to overcome the resistance by the molecules on the surface. समझे? ठीक है? इट इज समथिंग लाइक कि क्लास में बच्चे बैठे हुए हैं, कोई नया बच्चा आता है तो जो क्लास में बच्चे बैठे हुए दे डोंट वांट हिम टू कम। कहता नहीं यार यहाँ मत आ, चलो उधर चला जा, बाहर रहे, इस तरीके से रहे, पास मत आ, हमारे लिए जगह है, काइंड ऑफ दैट। सो दिस हैज टू exert an extra pressure. As we keep on increasing the temperature, the vapor pressure keeps on increasing. And there comes a time when the vapor pressure becomes equal to the external pressure. अनन्या सरकार, हम इतने सारे माइंड मैप बना रहे हैं बेटा। व्हाट डू यू मीन बाय माइंड मैप? क्वेश्चंस करो मेरे साथ, मिल जाएंगे माइंड मैप्स। फ्लो चार्ट, ठीक है, मिल जाएगा। बट हाँ, इसको पढ़ जरूर लेना। अब 380 स्लाइड का तो फ्लो चार्ट नहीं बनेगा ना, एक एक स्लाइड का बनेगा ना। So the gas molecules, the external pressure is there. Now, all molecules do not escape out. The resistance from the molecules of air present over the surface. समझ में आ रहा है ये? Are you able to read it, through it, understand it? As we keep on temperature, as we keep on increasing the temperature, the average increases. The surface energy remains the same. It doesn't need to increase because the moment it increases, the molecules are going to move out from the surface. So the surface energy remains the same, but the energy of the bulk is increasing. And there comes a time where the energy of the bulk and the surface becomes equal. The difference between them keeps on decreasing. And at some time, it's going to become equal. Now, the molecule from the bulk does not have to stop at the surface. It simply moves out. Now, this becomes a bulk vaporization. The bulk vaporization is called boiling. Is this clear? So vapor pressure becomes equal to the external pressure. When the vapor pressure is equal to the external pressure, the molecules moving from the bulk do not have to pause at the surface. They simply move from the bulk to the vapor. Now it is not a surface phenomenon, it becomes a bulk phenomenon, and the bulk vaporization is called boiling. So that is what we have as boiling. And when we talk about boiling, the temperature at which the vapor pressure becomes equal to the external pressure is termed as the boiling point. And you need to remember The boiling point depends on the external pressure. You change the external pressure and you change the boiling point. Clear? If you increase the external pressure, the air resistance increases and the vapor pressure, that is the temperature, needs to be increased to balance it. So as the external pressure increases, the boiling point increases. As external pressure decreases, the boiling point also decreases. You can actually make the boiling point less than the melting point, and that's what we become, but that what becomes sublimation. Is it clear? There are two kinds of boiling point. One is called the normal boiling point, and then is called the standard boiling point. The normal boiling point is the temperature at which the vapor pressure becomes equal to 1 atmosphere. Now that temperature is 373 Kelvin for water. The standard boiling point is the temperature at which the vapor pressure becomes equal to 1 bar. Now 1 bar is less than 1 atmosphere. So that would simply mean that the normal boiling point is less than the standard boiling point. No, standard boiling point is slightly less than the normal boiling point. So normal boiling point is slightly higher than the standard boiling point. Is that clear? Now let's talk about something called the melting point. So melting point is a temperature at which the liquid and the solid state of a substance coexist in equilibrium with each other. Okay, the liquid and solid are continuously interchanging, but the mass of each of them remains unchanged. So again, it's an equilibrium. Now this equilibrium is established when the vapor pressure of the solid and liquid becomes same. Clear? That's what we have talked about in the solution chapter as well. The vapor pressure of the solid becomes equal to the vapor pressure of the liquid. That is the melting point. The state which exists at any given temperature is the one which has the least vapor pressure. जिसका वेपर प्रेशर कम होता है वो स्टेट एग्जिस्ट करती है. याद है सॉल्यूशन चैप्टर में किया था हमने ये. Okay. So the melting point is again a manifestation of vapor pressure. It is the temperature at which the vapor pressure of the liquid is equal to the vapor pressure of the solid. किसी को कोई कंफ्यूजन? कुछ पूछना है? We have already talked about. Now the gas is a substance above the critical temperature. Liquid vapor equilibrium. Fine. So we have just talked about the phase equilibrium. Okay. In the evening at 4 p.m. we are going to start with the chemical equilibrium. Any confusions? Any problems? Mayuk Sen Gupta, vapor and liquid coexist at any temperature. Vaporization takes place at all temperatures. Evaporation takes place at all temperatures. Okay. At boiling point, the vapor pressure becomes equal to the external pressure. Is it okay? Fine. So we have just talked about the boiling point, the melting point, the freezing point. So here we have the biggest offer. You can go along with our sessions. 2 p.m. Botany, Swati Batra ma'am is going to take. And I believe you have a session at 1 p.m. also with Sachin sir. At 3 p.m. today, I believe you are having a mega quiz with Sachin sir and Swati ma'am both. And 4 p.m. again, you will be with me with chemistry, chemical equilibrium. And this time we are going to start with the chemical equilibrium. And we are going to start with something called the active mass. Join with the Telegram channel. Okay. Join with the YouTube class, PDFs, NEET UG subscription. Well, NEET UG subscription would mean you can join it using the code AV Live, and then you will be able to get the access to all the courses in NEET UG. कमाल है ना, सारे कोर्सेज का एक्सेस मिल जाएगा. द ओनली थिंग इज, डू यू नीड इट? इफ यू नीड इट, go ahead and take it. Okay. Join with us in unacademy.com/Anoop Vashisht. That is my page on Unacademy. And subscribe to NEET Elixir by Unacademy. Okay. Take a rest. 1 o'clock, you have again the class. Bye bye. Thank you. We'll meet at 4 p.m. and then again at 8 p.m. today. Bye bye. Good day.